Hello and welcome to the part 2 of the National Weather Service Winter SKYWARN Spotter Training program. This is a part 2 of the 6-part video series to go through this program and to help any sort of trainee to become a weather spotter for the National Weather Service Pittsburgh office. In this video, we're going to be discussing the different types of forecasting techniques and weather monitoring tools that the National Weather Service uses or a meteorologist might use during a winter season to help us understand and figure out what sort of winter weather may come. The first thing we're going to discuss is weather forecast models. This is terminology that's been used a lot and maybe people don't fully understand what it fully means. A weather forecast model is basically a computer model that utilizes mathematical equations to help estimate and predict what may occur in the future based on what it knows is currently ongoing. We have a lot of different assumptions and things that we think can help to measure how weather works and how these fluid moves through the atmosphere, but not everything's totally accurate. So with the different ways that we can compute some of this information, it allows us to create different sort of scenarios. So when we use weather models, some of them are just individual scenarios. If you take, for example, the Global Forecast System or GFS model, that is just one attempt using computer modeling information to guess what's going to occur in the future. What we utilize within the National Weather Service is that model along with a whole host of different models. This allows us to give a whole wide range of different possible scenarios of what could happen in a given weather event. Take, for example, a winter storm. We think a storm might be coming in, but we sometimes don't know how much snowfall accumulation occur. What we use is something like a national blend of models, which is a blend of all sorts of different models to help to try to give us a different range of different possible scenarios and outcomes of that winter storm coming in. So we can know whether it's going to be 6 inches, 12 inches, 4 inches, or how likely different amounts may occur. When we're using weather models, sometimes we have high confidence. What that means is with weather models, all these different weather models and scenarios are actually coming out to the same conclusion. Again, in a winter storm scenario, they're all saying there's going to be 5 or 6 inches that fall in Pittsburgh. If 100 different weather models all say the same thing, that gives us high confidence that that weather forecast is going to occur, and that's part of our forecast process. Sometimes, however, especially with winter systems, when things like just a few degrees temperature can change the type of precipitation, or the low may move 20 miles this way or that way, that can change the band of heavier snow, we can have a lot wider range of potential outcomes, which causes maybe lower confidence. We have seen scenarios where this suite of, say, 100 different models shows scenarios from anywhere from maybe 1 inch of snowfall all the way up to 20 inches of snowfall. What do you do with that? Well, so what we do is try to find where there's most consensus and use this different information to help highlight the different ways that that forecast may alter from our base deterministic forecast. So we might say, hey, we're expecting 6 to 8 inches of snow in Pittsburgh, but here's how what scenario may play out to cause that amount to change. Say, we've seen it many times before. If warm air works farther northward up the just to the west of the Allegheny mountain range, then all of a sudden we could go from that 6 to 8 inches to maybe only 2 inches. Now, if that warm air doesn't cold in or something else on, this is how it could be 16 inches. So while we have a feeling of what may occur, what we're starting to use is this range of different weather models to create the possibilities or probabilities of different amounts. It helps to better frame how a winter system may play out. This stuff is very difficult, and only, again, a couple degrees difference, a couple mile difference can drastically alter what occurs at one single location. But utilizing this range of different outcomes helps to give us more information to provide to you to help you understand the different ways that this winter system may play out. Along with weather models, we're also trying to monitor what is actually occurring in the near term. For example, a lot of state agencies and Department of Transportations have road cams or different video cameras that are going on. We utilize those all the time to monitor whether snow is falling or not, whether it may be freezing rain, and then more notably, whether it's sticking to surfaces like grass or even roadways. That can really help us to communicate what potential impacts are going to be seen over the coming 3, 4, 5, 6 hours. We also have data sets that allow us to see area road temperatures. This is very crucial to know whether snow may stick or may not, or in the cases of freezing rain, whether falling rain may actually freeze on roadways and really cause a lot of serious issues. We utilize that information. We also utilize weather radar as well as surface observations. It may be hard to tell in this image here, but the various numbers and dots correlate to actual weather observations that are occurring at airports all across the region. These airports are fitted with automated weather sensing systems that provide things like temperature, dew point, wind speed, wind direction, and as well as what sort of weather is falling, snow, rain, and how heavy it is, as well as what your visibility is at that given location. All that information is very crucial when we're having to make decisions on where the snow line is versus the rain line is, where the heaviest bands are, where visibilities are much lower than other areas. And we can utilize this information to provide it through our aviation forecast discussions, through our social media channels, to help with folks to make better decisions as they go out into those roadways. One of the key crucial tenets for our weather forecast models, along with all the surface observations that go into them, is also our daily upper air soundings. The National Weather Service Pittsburgh office is one of 92 upper air offices that launch a weather balloon 2 times a day, every single day. This weather balloon goes through the entire atmospheric column and collects temperature, dew point or moisture, as well as wind speed and direction information through the entire column. This is very crucial to know what's not only occurring at the ground, but all the way through the atmosphere. All this data is then fed into those weather models to help to make them more accurate. But it also helps us to diagnose where maybe warm layers aloft are, which we'll talk about later, that might alter the different precipitation types. Again, these weather observations are done twice a day, every single day. There's also weather information that some airplanes actually have with weather equipment on board that help us give us real-time live data in between those different weather balloon launches that we do at our office. I mentioned radar before, but radar is also a great weather observation tool that we use at our office. With the new dual pole capabilities that it has to be able to differentiate the different types of hydrometeors, our radar capabilities will actually allow us at times to differentiate between the different types of precipitation that may occurring by seeing things like the melting layer. A melting layer is the layer that falling snow maybe melts because of warmer air and changes precipitation type. So during an ongoing event, it helps us to distinguish between different precipitation types like heavy snow or heavy sleet or heavy rain, to know where impacts might be, again, more impactful. The one problem with weather radars, though, is that given the curvature of the Earth's surface, the radar beams tend to go up higher and higher through the atmosphere as you get farther away from the radar. The beam is going out straight, but because the Earth is curving, those beams gradually rise up. With winter precipitation, a lot of times it occurs closer to the ground. So as you go farther away out from the radar, a lot of times the radar beams are overshooting that precipitation and make it harder to pick up whether it's actually falling or not, especially when it's things like lake effect showers coming off of Lake Erie. So a lot of times, while we have these systems and things like radar to see the precipitation, it's still really helpful to have surface observations and reports that let us know what's going on, because we may not be getting the full clear picture. So that's just a little bit glimpse into the different weather tools that National Weather Service Pittsburgh meteorologists may use during a winter season. If you'd like to learn more about our winter weather and other information, how you specifically can help us, look into the comment section for more information on this series and to view the next video. Otherwise, we say thank you very much for your attention, and you have a great day.